What's cooking, potatoes? On this episode, we're going to check out how much current the Arduino has to supply to get anything out of this floppy drive, and also what the maximum frequency we can get up to before this starts fucking up. This is the program we had in the last episode. Just gonna cut this stuff out. We're gonna look at the current, the direction pin outputs. So we're just gonna have this. And we might as well leave this in here, just so we know it's working. Upload time. That's interesting. It's not doing anything. Why isn't it doing anything? Alright. No? Oh, that's right. Yeah. I shifted the pins up to 2 and 3 because 0 and 1 are used for serial communication, and I wanted the serial communication for outputting the frequency when we're testing the frequency. So I just changed these all up. Yeah, you know what? Let's do it properly. You may argue I should have done this at the start, and you are correct. But laziness. So, that looks to be 0.1 milliamps. (103 microamps). Not to be trusted, I'm assuming this multimeter isn't very accurate. It costs like $6, so that's good. That's very good. We probably ought to test the step pin now as well. I turned the power supply off and now it's saying 4 milliamps. That's interesting. Assuming that's to do with the internals of the floppy drive. Alright. Yeah. So now we'll want to just have this one be written high as well and not do anything in here. Otherwise we'll get like some sort of weird average value or something out of the multimeter, I would expect. So we're getting like 4 with the power supply off, probably because of some like resistance stuff inside the floppy drive. And again, it's 0.1. This is all very good, because it means we can put a bunch of floppy drives on there and not have to worry about... I mean, I expected it to be like this, really, because it'd be kind of weird if it was drawing huge amounts of current, because it's just like a control signal. Let's check the ground thingy. Is it not gonna fit? Come on. Yay! Good enough. How to do. Yeah, let's just hold that up. It'll be fine. It'll be absolutely fine. Huh. 4 milliamps. That's a bit higher than I expected, but it should be fine. She'll be right. She'll be right. Alright, it is now time to test the frequencies that this can output. So, I have this Miniterm application here, which is an example application provided with the Python serial library. So, we're using that to have a look at the, pretty much I'm just going to send like the frequency or the wavelength, whatever, that it's currently playing. I'm going to make it play a bunch of sounds. And then, when I hear the sound start to screw up, because eventually, as we saw, the step mode is going to like go WTF, too difficult, I'm out, right? So, I'm going to hear when it fucks up, and then I'm going to see what the frequency is. And that way, we're going to calculate the maximum frequency that these things can do properly. And I think it might depend on the on how we're actually playing it, whether we're just like flipping the direction every time we pulse the step pin, or if we're actually allowing it to move. So I'll test that as well. I'll test a bunch of things, and we'll see what happens. Alright, so let's get rid of this. I think we'll have a function to play a specific tone. Let's see, we'll have wavelength in microseconds. And I don't want to just use like delay here, because it'll probably, if I write this, right, it'll probably take slightly longer, so the frequency will be slightly lower than because like this function will take time to execute, this function will take time to execute as well. So this is more like, I reckon it's more like wait at least this amount of time. Yeah, so instead, let's do let's do that. So busy wait loop, keep going until, whoops, divide by 2 here. I think I messed that up in an earlier video. So yeah, busy wait loop until we've exceeded this. Also, I believe the Arduino, this model, has the resolution of the microsecond timer is like 4 microseconds. So it'll be fine. I can. This is probably. I need to put this before here. Oh, no, I don't. I need to put it like directly after the pin is actually gone high. Well, whatever. Good thing about this is when I'm actually trying to get it to play files, I'll need to do processing. But the processing, if you have large chunks of processing, it'll mess up the stuff that's trying to play. So these waiting times, I reckon, are the best time to actually do processing. So we'll have something in this form anyway, except instead of like busy wait loop, it'll be do stuff loop instead. And now I also want to do something with the direction pin in here. Let's just have it oscillate for now. And since I'm horrible at I'm pretty horrible at like trying to work out what a particular frequency control responds to what wavelength because it requires thinking. So I need a calculator. Alright. 440 hertz. Alright, here we go. 1 over 440. Alright. That's the number of seconds. That's it. Yeah, okay. Times 10 to the power 6. Number of microseconds each thing should last for. Alright, so we'll put 2272 here. Ah! Even though your product is excellent, I still won't buy it. Alright. Here we go. Not sure if you guys can hear that. I have the microphone over near the computer, not near the thing, but it's making a... It's making a tone. I don't know, it sounds a bit high to me. Let's change the... Well, first off, let's change this back to delay microseconds and see if there's any difference. So if it sounds lower, then I was totally right. It sounded a lot lower that time. Like, a lot lower. It also yeah, I don't know. I don't have like a piano or anything, so, and I suck at music, so I can't check if that's like a lot higher. Alright. Let's have like 100 hertz note instead, or like some really high. Let's make it 6,000 or something, right? And then we'll swap it and we'll see if the difference is less. Because the alternative is this is like wrong somehow, but well, that was just weird. What? See, that sounds much more normal. What? Alright, hang on. Let me just check something. Alright, 6,000? What is being normal now? Why? Why? Why am I getting trolled so hard? It's probably something to do with it. Yeah, it's probably something to do with it bashing up against the like, it's not being far enough out. But I think that is lower. Weirdness. You know, for a second there, I thought the compiler was just trolling me and optimizing out those busy wait loops. But that'd be that'd be pretty strange. Alright, let's actually do this thing and have it move a little bit. $50 seems alright. Now we shouldn't get trolled by that direction stuff. What? Now it's being retarded. Ah. Alright, this is so confusing. Alright, watch this. Alright? Use delay microseconds, right? And you see, yeah, that's what we expect, right? Alright, well, I use this busy wait thing I have here, right? What is this shit? Come on. What is this shit? It's, you know what? Just to be sure, I'm gonna put something in here. Right? Just to be sure the compiler isn't like removing this. What? What? This doesn't make any sense. Oh, you know what? I'll just deal with this later. This works. So we use this for the time being, and I'll see if I can work out what the fuck is going on with that shit later. Alright, cool. Alright, so we need some cereal thingies. Delicious cereal. And mini term as well. So, we need to keep count of the time. So t equals 0. And let's make it millis actually. Cool. And what do we want it to start at? Let's start at 10,000. Take and so time since start, I reckon. So t take millis take t. Over a period of 10 seconds. Let's make it a little bit slower. And then we'll say if millis take t, control parentheses, is greater than 40,000, then t equals milli. So it'll just wrap around. And then we'll play our tone. What? Alright, so expect to hear something that starts off low and then it gets higher and then it eventually goes back to the start again over a period of about what? 1,000 milliseconds in a second. 40 no, change this back. 10 seconds. I don't want to have to wait 40 seconds for this. Alright, it's going. Now, I'll bring the mic closer. It's pretty funky. See, it starts to fuck up towards the end now. What? Why is it doing that? It ended up... Whatever. Anyway, let's print out the wavelength we're at. We can't do this every loop, otherwise it'll completely mess up what it's playing. So maybe every 1,000. Yeah, every time it adds another 1,000. Alright. Yep, add some more global variables, you know, why not? It'll be totally awesome. Yep, great name we have here, count. Alright, we'll just call this 1,000 then. Yeah, why not? Let's just store the previous one. Yeah, alright. Then we won't have multiple calls to millis and things. May make a bit more sense. It's a pretty retarded variable name, now I come to think of it. Previous. We're using it as if it's the current, or whatever. Yep. And now we move this over here. Alright, this shouldn't mess up like the frequency too much. Yeah, that looks like it's working. Cool. Alright, sounded normal, sounded normal. Started to get messed up around 3000, which is really weird because around 2000 is, you know, A4. It's fine. It's still fine. Getting softer. Started to fuck up right there. Okay, so this says it's fucking up, like, in between here. I'm not sure of, like, how instant this is. Like, when this prints. Like, how long it takes for, you know, this to actually come out and get printed on there. So, I suppose we could test it. Nah, who needs it? I think I'll just try playing something that it says it fucks up, which is 2000 with what we have currently. And if it works, then there may be a delay, or maybe it's something else. Yep. Yeah, okay, except it wasn't moving when it did that. Why wasn't it moving? It should... Man, this stuff is so confusing. Like, you think it worked, and then it's just like, not gonna do something weird, bro. Fucking hardware, honestly. I know the information, like the maximum frequency you can get out of this floppy drive is on the internet, so I actually have to go look it up and see how it compares to what the results I have here. Admittedly, I don't really have that many results. Things have just been like going like WTF. I don't know, I'll see you in a bit. Alright guys, I just got trolled pretty hard. Yep. Had to be... See, the documentation said from the start of the program, right? And it takes 17 minutes to overflow, which means it's gonna be... It should be under 2 billion for the first 35 minutes that the program is running, but apparently not, because this thing, right, I noticed I was printing out this value, right? This was off screen. I was printing out this value to see what the hell was going on. And it was negative. I was like printing it through zero. It's negative, and I was like, that should not. But yeah, unsigned. Got trolled. I hope that never happens again because that was annoying to work out. But as it turns out, this method here, doing this, is more accurate by about 40 microseconds or something. And also, researching on the internet from people who've done this before, it turns out that yes, the maximum frequency you can get out of these floppy drives is about 420 hertz, which is kind of bad actually. I don't know. No, it's all right. After you, as you saw, after you go past that, the little head it starts moving. Like, yeah, I don't know. Whatever. But at least we know now. At least we know. And this, and but yep. It turns out this method here, doing this, is more accurate by about 40 microseconds or something. And also, researching on the internet from people who've done this before, it turns out that yes, the maximum frequency you can get out of these floppy drives is about 420 hertz, which is kind of bad actually. I don't know. No, it's all right. After you, as you saw, after you go past that, the little head it starts moving. Like, yeah, I don't know. Whatever. But at least we know now. At least we know. And this, and but yep. I reckon that was about 15 to 30 minutes of me being a retard. No surprises there. GG, broski.